And one more example now. Sand is poured into a pile that remains conical. Now think about what a cone looks like, with 45-degree sides. Now as you read something, think about how you're going to use that piece of information. If it's got 45-degree sides, in fact I haven't really drawn it fat enough, have I? It needs to sit out more like this. Then we've got the height of it here, and we also know that the radius here and the height are going to be the exact same. How can we tell that? Well, a 45-degree angle on the sides means that we've got a right angle here. This is also 45. So the gradient of this line is 1 as you go around, or -1, depending on which side you're looking at it. But we also know that that makes these two sides the exact same. So, first thing I would do here, well, let's finish reading the question. It's pouring in this sand at the rate of 3 cubic metres per minute. Now, let's write down what that means. We've got a change in volume over time of 3. And you can put the units on that as well if you want to. So that's something we know. What else do we know? Well, we know something about the volume of a cone. So let's think we've got the formula, 1/3 times the area of the base, which is pi r squared, times h. Now they've given us this clue for a reason. I'd say that we need to either make everything in terms of h or everything in terms of r. Let's have a look at our question. It says find when the height is 2 metres, so they're telling us about the height. Find the rate at which the height is changing. Well, it looks like we're really interested in the height. So that tells me that if we know that h and r are equal, then we can swap one in for the other in this formula. So instead of writing it this way, I'm going to say that's the same thing as 1/3 times pi times not r squared but h squared times another h. So I've actually got h cubed. Now my volume is all in terms of one pronumeral, h. That tells me I can easily differentiate v with respect to h. I can bring the 3 down here and it will cancel with the other 3. The pi will come along for the ride because that's just a constant. And h cubed is going to change into h squared. So now I've got that. That's important. So I know dv dt. I know dv dh. How am I going to relate those? Well, I need to find the rate at which the height is changing. In other words, and this is handy to jot down so that you're changing your worded question into your mathematical format, I need to find the rate of change of the height over time. That's what I'm looking for. Okay, so let's write down what we want first, and then think about how we can use these two things to get it. If we multiply this by this, are we going to get that? We're not, are we? Because look, they've both got dv on the top. So what can we do? Is there any two things here that can be multiplied to give the other one? That's the way to look at it. Look at the two you have and the two that you want. Well, these two both have dv on the top, and those two both have dt on the bottom. So it's not these two multiplying together. It's not those two multiplying together, so it must be these two. See how I worked it out? There's 3 ways that you can choose two things. And the first 2 choices didn't make sense, so I chose the last one. So I know that if I multiply these two together, I must get this one. And sure enough, checking, the DH's will cancel and I'll get dv dt. Now it doesn't matter too much how you write this. In the earlier example, we wrote this part first and then the things that we multiplied by to get it. But you can see here, you need to be quite flexible with your thinking. You need to take the clues that you've got, write down what they are, write down what you've found, write down what you know, and then look at how you can make them talk to each other in this arrangement. Once you think of it like that, it becomes much easier to problem solve it. All right, so what we're trying to find then is dh dt. So that's this. So that means that if I want dh dt, then I need to do dv dt divided by dv dh. All right, what is dv dt? That's 3. And I need to divide that by dv dh, which is this. I can write it as a fraction if I want to. Pi h squared. So now I've gone ahead and I've found a neat little formula for how the height is changing over time in terms of h. So you can see this is just a little recipe that tells me how the height is changing for any height that I want to investigate. And when they say, hey, when the height is 2, how is it changing? I just need to sub that in. So I will write when h equals 2, the change in height over time is 3 over, now 2 squared is 4, so I've got 3 over 4 pi. And height is something that's in centimetres. And if we're looking at how it's changing per minute, oh, hang on, it's metres, isn't it? Height is measured in metres all the way through here. Metres, got metres, so we need to do metres per second. And we're done. Now for the second part, they're saying when the height is 2 metres, find the rate at which the area of the base is changing. Now let's consider the area of the base. The base was just, if we say, let A be area of the base, then we know that area equals pi r squared. But remember, we also knew that if there's 45-degree sides, we were changing our r into h because we knew it was effectively the same thing. So we've got a little formula now for the area of the base, and we want to know how the area of the base is changing over time. Well, I can differentiate the area with respect to the height just by bringing my 2 down. The pi comes along for the ride, and I get 2 pi h. So I've got that. Now at this point, if you feel stuck about what to do next, go back to the question and say, what do I want? I want to find the rate at which the area of the base is changing. So I want the area, how it changes over time. And I've got, write down what you have, and then you can see what you need. Okay, so I need the dA to be there, but I need the dH to cancel out, and I need dt. So I need how the height is changing over time. And we've already found dH dt when the height is 2 in the first part of our question. So we really just need our answer in A, that's dH dt, when the height is 2. So now I can go ahead and say I need dA dH, that's here, 2 times pi times h, but remember I want to let h be 2, times 3 over 4 pi. And now we can tidy up, the pi's are going to cancel, the 2 times 2 will cancel with the 4, and I can say that the answer is 3. Now 3 what? We're looking at how the area of the base is changing, and we're talking about a pile here that's, everything is in metres, so it's changing at the rate of 3 square metres because it's area per minute. And we're done. So these questions can seem really tricky because you get bogged down with thinking, what am I trying to find again? So I know I do a lot of circling of things and underlining of stuff. I generally turn anything that I see in my question as a clue into a little piece of math straight away. Notice as soon as I saw that, I drew a picture. I also turn the worded parts of the question into the notation that I'm going to need. And then my other strategy, which I highly recommend, take the thing that you know and the thing that you want and write them down and have a look at them. Because sometimes it's easy, you just multiply the 2 together, but sometimes it's a little bit more difficult and you need to work out which 2 things need to be multiplied together to make the third one. And sometimes your unknown will be one of these. Sometimes it will be that. So don't be too prepared for them all to be the same. You've got to work it out freshly each time. But these sort of questions are actually quite fun and satisfying when you get to the end of them, just because they can be quite involved.